morning to one and all. I'm Dr. Sumitra from CSC department, and today we are going to discuss all about a deep recurrent network. The deep network is all about in a realm of artificial intelligence and the machine learning. A deep recurrent network stands tall as a formidable tools for handling a sequential data. They are designed to capture the ingredient patterns and dependency with the sequence, making them invaluable in a wide range of applications from a natural language processing to a time series analysis. Let's have a divert into a depth of a deep recurrent network, exploring their definition, layer, types of applications, and the innovative mechanism that makes them so powerful. As we can also state that a recurrent network is a type of a neural network specifically designed to model a sequential data by maintaining a memory of a past input. Unlike a traditional feed-forward neural network, which process each input independently, a recurrent network have a connection that forms a directed cycle, allowing the information to persist. This persistence of information enables a network to capture the pattern over a time, making it ideal for tasking including sequence like speech recognition, machine translations, and the sentiment analysis. The layers of the deep learning neural network is all about a deep learning neural network consists of a multiple layers which serves as a sequence serving as a specific purpose in a processing a sequential data like a input layer, recurrent layers, and the output layers and the hidden layers. And here is a diagram that shows you the basic layers of a deep recurrent networks. As an input layer, this layer accepts an input sequence where it's a series of words in a sentence, framed in a video or a data point in a time series. We have a recurrent layer where these are the heart of the network containing a recurrent unit that maintains a memory of previous input. Each recurrent unit processes a current input along with the information from the previous time steps, allowing the network to learn a sequential dependency. And we have an output layer. The final layer of the network produces output based on the processed sequence. This could be a classification, predictions, or a generation task depending upon the application. We have the types of a deep recurrent networks like deep NSTM network, deep GRU network. The deep NSTM network is a short term memory. Units are designed to address a vanishing gradient problem in traditional recurrent network. They maintain a cell state, allowing information to follow through the network without a significant degradation. A deep LSTM network consists of a multiple LSTM layers which enable them to learn a complex temporal pattern. We have a deep GRU which is graded recurrent unit which is similar to that of LSTM. GRU unit also address the vanishing gradient problem. They have a fewer parameters compared to LSTM, making them faster to train and more computational efficient, whereas the deep LRU networks are constructed by stacking a multiple GRU layer, offering a similar capabilities to deep LSTM network. Bicurrent recurrent network, bidirectional recurrent network process sequence in a both forward and a backward direction by capturing the information from the past and future context simultaneously. Bidirectional network excels in tasks where context from both directions is crucial, such as speech recognition and the mission translation. We have a hierarchical recurrent network. The hierarchical network organizes a recurrent unit into a multiple levels or hierarchies. Each level processes information at a different temporal scale, allowing the network to capture the pattern at a various level of abstractions. We have a deep residential network, whereas it which is inspired by a success of residential connections. In a convolution network, a deep residential recurrent network uses a residential connection to mitigate the vanishing gradient problem. These networks allows for the easier training of very large architecture by enabling the gradient to follow more effectively. And we have an attention mechanism where This attention mechanism enables the capabilities of recurrent network by focusing on a specific part of the input sequence. It assigns a different weights to the different part of the sequence dynamically, allowing the network to pay the attention to the most relevant informations. We have the applications where the versatiles of a deep recurrent network leads to a application across various domains like natural language processing, speech recognitions, and time series forecasting, gesture recognition, robotics, and so on. As a natural language processing, the tasks such as mission translation, segmental analysis can also be used, and the speech recognition where you can process audio signals over time and convert them into text. When a time series can analyze the historical data to an accurate future predictions, and the gesture recognition is just for complex sequential data. So hence I conclude by saying that deep recurrent network represents a sophisticated approach to modeling a sequential data. Thank you, one and all.